Students, welcome to Swifto. Now we are going to see heating effect of electric current. Okay, so இது வந்து ரொம்ப ஈஸியான டாபிக் தான். ஸோ ஃபர்ஸ்ட் பாயிண்ட் பாருங்கள். ஸோ பேட்ரி ஆர் எ செல், இட் இஸ் a source of electric energy அப்படின்னு படிச்சிருக்கோம். ஸோ do you remember when we were studying about potential difference? ஸோ potential difference படிக்கக்குள்ள ஞாபகம் இருக்கா? ஸோ இந்த பேட்ரி தான் வந்து பார்த்திங்கன்னா அந்த எலக்ட்ரிக்கல் எனர்ஜி க்ரியேட் பண்ணுச்சு, அந்த பொட்டென்ஷியல் டிஃப்ரென்ஸ் க்ரியேட் பண்ணது பேட்ரி தான், ரைட்? பேட்ரி இருக்கிறதுனால தான் அந்த கரண்ட் வந்து மெயின்டைன் பண்ண முடியுது ஒரு சர்க்யூட்டில் அப்படின்னு படிச்சிருக்கோம். டூ யூ ரிமெம்பர் தட்? ஸோ பேட்ரி ஆர் அ செல் இஸ் அ சோர்ஸ் ஆஃப் எலக்ட்ரிக் எனர்ஜி. ஒரு கெமிக்கல் ரியாக்ஷன் நடக்கும் ரெண்டு டெர்மினல்ஸ் ஆஃப் த பேட்ரிக்கு நடுவில். ஸோ அப்போ வந்து நம்மளுக்கு வந்து பார்த்திங்கன்னா இந்த மெயின்டைன் பண்ண முடியும் எலக்ட்ரிக் கரண்ட் அப்படின்னு படிச்சிருக்கோம். ஸோ கெமிக்கல் ரியாக்ஷன் வித்தின் a cell generate the potential difference between its two terminals that sets the electrons to flow, which is the current that flows through the resistor or a system of resistors ன்னு படிச்சிருக்கோம். ஓகே, ஸோ இந்த பேட்ரி வழியாக வரக்கூடிய இந்த potential difference, because of this potential difference that has been set up due to a battery, the current flows through each resistor, right? So this is what we have studied earlier also. ஓகே, இப்போ இதுலேருந்து வரக்கூடிய எனர்ஜி வந்து பார்த்திங்கன்னா பாதி வந்து கரண்ட்டை மெயின்டைன் பண்ணுறதுக்கும் பாதி வந்து ஹீட்டாகவும் டிசிபியேட் ஆகுது. ஓகே, the source of energy is partially used for maintaining the current and the rest of it will be dissipated in the form of heat. Okay, so the circuit வந்து பார்த்தீங்கன்னா completely resistive-ஆ இருக்குது, அதாவது completely made up of resistor-னா then entire energy வந்து பார்த்தீங்கன்னா it's going to be dissipated as heat. If the circuit is found to be purely resistive, then the energy will be entirely dissipated as heat. Okay, now we are going to derive this mathematical relation. Okay, wow. So what is this heat that is released? Okay, so we'll understand this. So what is the formula to calculate that heat that is released? Okay, so we'll go forth now. Okay, so we have studied in 9th class that, so what is energy? Okay, energy is nothing but, so energy is whatever the work done. Okay, the work done is what basically stored as energy, right? So if we know the work done, you can easily calculate the energy, right? So what the work done, that is what basically stored as energy. This is what you have studied in 9th class, and you know very well. So what is this potential difference? That is work done per unit charge. Okay, so work done per unit charge is your potential difference. Now, so if you want to know this work done, so you can take this one to this side. So the q in the பக்கம் போயிடுச்சுனா, so என்ன ஆன்சர் வரும்? v into q is equal to w. So the work done. இப்போ power, so power என்னது? power is nothing but rate of doing work, that is work done by time taken. Okay, work done by time taken na power. அப்போ power சொல்லுங்க. So power will be equal to v q by t. Okay, so இதுதான் வந்து பவருக்கான இப்போ ஃபார்முலா. ஸோ p is equal to v into q divided by t. இப்போ q by t னா என்னது? So you know very well, q by t is nothing but current. The rate of flow of charge is current, right? So அப்போ பவருக்கு வந்து ஃபார்முலா வந்து பார்த்தீங்கன்னா v into i. Okay, so this is the formula to calculate the power. Okay, so you can remember this result also. Okay, so p is equal to v into i. So this is the important conclusion which we have derived now. So now be careful. Now we want to know the heat energy that is released. Okay, now if you know the power, so power is equal to work done divided by time taken, right? So work done divided by time taken. So this work done, I told this is energy only, so you can replace here with energy also, energy by time taken. Now, so the heat energy that is dissipated, the heat energy will be the energy by just now we have seen here. So energy by time taken will be equal to power. Okay, now the heat energy that is dissipated will be equal to the heat energy that is dissipated, I am denoting by the letter h. So take this t to this side, p into t. Now just substitute the power from this equation. Okay, the power will be equal to v into i. Okay, so this is the formula to calculate the heat that is dissipated. Now using the Ohm's law. Okay, so using the Ohm's law, you can substitute the value for this v. Okay, you know very well from Ohm's law, v is equal to I into r. So just substitute that here. So h is equal to I into r into I into t. Okay, so that I into I will be I square rt. Okay, so this is the derivation for joules law. Okay, did you understand this joules law? Okay, I square rt is the formula to calculate the heat that is dissipated. So from this you can clearly understand that the heat that is going to be dissipated will be directly proportional to the square of the current, and it is directly proportional to the resistance, and it is also directly proportional to the time. Okay, so this is the conclusion which we are going to derive from this Joule's law. Okay, so just remember this, it's a very easy derivation. Okay, so just you have to remember power is equal to V into I. So energy, the heat energy will be nothing but it will be equal to P into T. So I'm substituting in place of P, I'm substituting V into I. Then I'm replacing from Ohm's law, V is equal to I into R. So I into R into I into T will be equal to I square RT, and this is your Joule's law. Okay, so just remember this equation. Okay, so life is very simple. Okay, this is the thing which you have learned in heating effect. So heating effect கான ஃபார்முலா ஞாபகம் வச்சுக்கோங்க. இந்த இதுதான் ஜூல்ஸ் லா சொல்றோம். So current is heat is directly proportional to square of the current, and it is also directly proportional to the resistance. Okay, this thing you have to remember. Okay, this is very very important. And then next video we are going to discuss about, so we will be discussing about the applications of heating effect. Okay, so we'll meet you there. Okay, remember this conclusion that heat dissipated will be directly proportional to the square of the current, and is directly proportional to the resistance of the particular system. Then it's also directly proportional to the time for which we are passing the electric current. Okay, so we'll meet you there in the video of application of heating effect of electric current. If you have any doubt, do let me know in the comment section. நம்மளுக்கு வந்து வாட்ஸ்அப் குரூப் இருக்கு, டெலிகிராம் குரூப் இருக்கு. ஸோ கண்டிப்பாக இதில் ஜாயின் பண்ணிக்கோங்க. ஸோ do not hesitate to ask your doubts. Okay, bye bye.